Okay, in this video, we're going to talk about the sine and the cosine rule. So, before we do that, we need to again draw a triangle. This time, the triangle can be of any shape. It doesn't have to be. It doesn't be a right-angled triangle. Okay. So the sine and cosine rule applies to all types of triangles. Every single kind. Alright, it doesn't only have to be a right angle triangle. Okay, as you can see in this triangle, we have three sides, obviously, and we're going to name these sides as follows. The green is going to be A. Alright, the length of the green side is A, the length of the red side is B, and the length of the purple side is C. Okay, well, A, B, C, it doesn't really matter. You can name the purple side A, red side C, and green side B. It is not important, it's arbitrary. Okay, and then, similarly, we're going to name the angles that are on the opposite side of the triangle as the capital letter of the alphabet. As you see, for example, this angle, I'll name it big C. Okay, which means I have to make this C a little smaller. And this angle will be B, and this angle will be A. So as you can see, we will name the angles on the opposite side of the length. Okay, they're going to be related, alright? Okay, so what the sine rule says is that the length of B divided by sine of the angle B is equals to the length of A divided by sine of the angle A, which is also equals to the length of C divided by sine the angle C. Okay, so it's saying that the ratios of the length divided by the angles, the sine of the angles, will be the same for every single side. Okay, and the cosine rule says that the length of any one side, for example, if I take C squared, will be equals to the length of A squared plus B squared minus 2 times A and B times cosine of the angle that is related to C. Okay, which also, if you apply it to any other side of the triangle, it can be that B squared is equals to A squared plus C squared minus 2, because now we're talking about B, right? So it's A squared plus C squared minus 2 of AC cosine B. Okay, I just bracket this to let you see that it's a cosine function. Okay, so similarly, A squared is equals to B squared plus C squared minus 2B times C times cosine A. Alright, so this is the sine and cosine rule. At the end of this video, I'll prove to you why this is true. Okay, but what's more important now is to be able to use these rules to solve for questions. Alright, so most importantly, I need you to realize that these A, B, and C are arbitrary. So you can name them anything you want. Okay, but the most important thing that is you have to name the sides and the angles to be the same alphabet, but one can be capital, one can be not capital, so that it's easier for you to solve the problems. Okay, so what I'm going to do now is to erase all this. Okay, and we're going to do some examples so that you understand what this is about. Alright, so first we do a very simple example that will make use of the sine rule. Alright, so okay, this is the example. Remember, we can be using any kinds of triangles. It can be like this, it can be under and like this. You know, any kind of triangle, it works. Okay, sine rule and cosine rule works for any kind of triangle. Okay, so in this example, we have this angle as 35 degrees, which it doesn't really look like 35 degrees, right? Okay, so how about our I mean, it does look like, but okay, I'm going to redraw this. Alright, let me show you sine cosine rule in a more different light. Okay, so let's use a triangle like that. Okay, so this is 60 degrees, this is 35 degrees, and you are told that this is 5 cm, but I'll just use 5 for length. Okay, alright, so that's all you're given, and you need to find the length of this x. So, I mean, in order to solve this question, you need to first realize that maybe you can realize that this angle, this green angle, is related to this length, right? Because it's on the opposite side. Maybe this blue angle is related to this length, because it's on the opposite side, as you can see. Alright? And according to the sine rule, we know that, so I'm going to write using the sine rule, we will know that 5, which is this side, okay, divided by sine of 60 is equals to, the green one here, x divided by the sine 35 degrees. So bringing this over, it becomes that sine 35 degrees times 5 divided by sine 60 degrees is equals to x. And the answer for x will be 3.311 if you type it into your calculator. So remember that the angles are in degree. Okay, so as you can see, it's a very straightforward way of solving. Even if they ask you for example, the length of this, let's make it y. Okay, all you need to do is just to find the angle of this, which you can do it by 180 degrees minus 35 degrees minus 60 degrees. Applying the sine rule. Okay, so for example, 180 minus 35 minus 60 is 85 degrees. So this is 85 degrees. And to find y, just use the sine rule again. So for example, you can do 5, remember 5 here, divide by sine 60 here is equals to, see, y divided by this, right, sine 85 degrees. So give you that y is equals to sine 85 degrees, let's do some 5 times sine 85 degrees, because you bring this up here, right, divided by 60, sine 60. And if I type this into the calculator, it will give me, give me a minute, I'm typing it into the calculator, 5.75. Okay, so y is equals to 5.75. So you can use the sine rule to solve for angles and lengths in a triangle. Okay, so let me just do maybe another example where you'll be asked to find an angle. Okay, so the example will be as such. We have a triangle. I'm going to use black. we have a triangle. I mean, this triangle can be of any shape. I don't know. Alright, it has 40 degrees here. You need to find this angle, and you're given that this is 6 and this is 3. Okay, so same thing using the sine rule. You can see that again, red is to red, right? So 6 divided by sine 40, and I'm going to give this angle a value x that we are going to find what is it. Okay, so it's equals to green to green, green, right? Equals to x, no, equals to 3 divided by sine of x. So you can see that sine of x is equals to 3 times sine 40 divided by 6, right? Because you just bring sine x here, okay, then you can bring 6 down, and you can bring sine 40 up. So just basic algebra manipulation, which is equals to, if I'm going to type it into my calculator, it gives me 0.321. And taking the inverse, which gets sine equals x is equals to sine inverse 0.321, which is equals to 18.74 degrees. Okay, so that is all you need to know about the sine rule. Alright, so there will be some situations where the sine rule cannot solve the question, and it's when you need to use the cosine. One example of such a situation is when you are given a triangle and they are given this angle, let's say 50 degrees. They are given a length 5 and 6, and you're asked to find this length. Alright, in this situation you cannot use the sine rule, because if you try, you're going to have two unknowns in one equation which you cannot solve for. So if I don't believe you try it on your own. I'm sure you are able to apply the sine rule. Okay, so but of course the sine rule cannot be used here. It will not give you an answer. So you would want to use a cosine rule. Now cosine rule, it says that in this situation we're going to give this as x again. Okay, the unknown will be x. So using cosine rule, remember x squared, if you want to find red, right, is equals to, okay, now the other two lengths which will be given, that's 5 squared, black means black, equals to, okay, 5 squared, because you're given this length, right, plus 6 squared minus 2 times 5 times 6 cosine, and where's the opposite side? This angle, correct, 50 degrees, which is, if you type into your calculator, if you give me some time, it's 2, 5, 6 times cosine 50, you will get 22.43, and x is equals to the square root of 22.43, which is equals to 4.74. So this will be 4.74. Okay, so cosine rule is usually used when you are given an angle and the length of the side that is enclosing the angle, and they are given nothing else. So in this situation you have to use the cosine rule to find the length of the side. Alright, in another example, you can even be given, let's say I'm going to redraw another triangle here. So like this, right? So maybe this time you are given this angle, right? And you're given this length 6 and this length is 4, and you will need to find what this angle is when given maybe this length, 9. In this situation, you still have to use the cosine rule, and this is how it goes. All right. So remember, if this is the angle in question, this is the opposite side, right? So we have it that 9 squared equals to, okay, the two sides are 6 squared plus 4 squared minus 2 times 6 times 4 cosine this, which I'll put as x. Okay, cosine x. So now all we need to do is just to solve for this, right? What x is. So we can see that if you bring this whole expression over to the other side, you can get 2 times 6 times 4 cosine x equals to 6 squared plus 4 squared minus 9 squared. And if so we can find that cosine x is actually equals to 6 squared plus 4 squared minus 9 squared divided by this, which you bring over, 2 times 6 times 4, which is equals to, again, type it into your calculator, and you will get negative, get a negative number, 29 over 48. And taking the cosine inverse here, you can get x equals to cosine inverse of negative 29 over 48, which is equals to 127 degrees. So the answer is 127 degrees, right? In this triangle, it does not look like so because I did not draw the shape correctly. Okay, but it still applies to the whole triangle because it's arbitrary, remember. Alright, so right now I'm going to spend the rest of the time proving the sine and cosine rule, and I don't think you're tested about that, but it's good to know what it is so that you have a better understanding, and I am sure you will be able to understand it. It's not very difficult. Okay, to prove the sine rule, this is what we do. First, using the same kind of triangle, remember you can do any kind of triangle, alright? I just need to draw one more line down here, and the length of this black line should be h. Okay, so we can see that if that actually sine b, okay, take a look here, sine b is equals to opposite divided by hypotenuse, h over c, which if we change the this is just a comma, if we bring c over, we can get h equals to c sine b, right? And remember, this is small c, alright? This is not the angle, this is the length, c, small c, sine of b. Okay, and we can also see that sine c, this big C, is equals to opposite divided by hypotenuse. So that's h over b, and again you can see that h can be, by shifting b over to this side, b sine of c. So since h and h are the same, we can see that c sine b is equals to b sine c. And if I bring sine c over sine b down, we get c divided by sine c is b over sine b. So this is the first part of proof. Okay, and now if I draw another length here, oh yeah, I forgot to mention that this is a right angle. Okay, that makes a right angle here, and okay, maybe I'll draw the other one as yellow. Okay, so I'll draw a yellow one here. Alright, so this is the yellow one. Same thing here, right angle, name this G. Using the same rule, you can also prove that sine that A divided by sine A is the same as C divided by sine C. Just by seeing what G is. So what I'm going to show you now is this. So I'm going to write it here, okay, at the side. So we can see that sine of A is equals to G over small c, right? Opposite, hypotenuse. Sine of big C here is equals to opposite divided by hypotenuse, G over A. Similarly, you can see that G is equals to C sine of A, which you get from this equation, which is also equals to A sine of C. So same thing, using this part, we can shift it around and get C over sine C is equals to A over sine A. And since C over sine C is the same as this, you can just bring this down here, and it's A over sine A. So this is the proof for the sine rule. For the cosine rule, it's a little more complicated, but it still is very understandable. Okay, so I'm just going to erase this because it's kind of ugly now, and I'm going to redraw one. Okay, give me a minute. This is A, and maybe this down, maybe here. So in this case, I'm going to name this angle B. Similarly, I'm going to name this angle, I'm using green, right? Angle A, and I'm going to name this angle C. So the length of this is A. Oh, my bad, this length is C. This length is A, and yes, you're right, this length is B. Okay, now I'm still going to draw this H thing down, remember? H. But what I need to see is that I need to make this length R. Okay, this length R. Okay, this length that I'm showing you. Maybe I'll draw in yellow. Yep, this, oh gosh. So this length is R, which gives us that this length here is actually B minus R, right? Because if the whole thing is B and this small length is R, this is B minus R. Okay, so we can use Pythagoras theorem to see that A square is equals to H square plus B minus R square. Because H is here, B minus R is here, right? And you can see that sine of A, which is this angle A, is equals to H divided by C. This is opposite hypotenuse. And this gives us that H is equals to C times sine A. Okay, we also see that cosine A, which is this A, is adjacent divided by the hypotenuse, which is equals to R over C. It gives us that R is equals to C cosine A. So you can see that if by using this equation and substituting in what H is and what R is, we get that. Okay, so how do we substitute? Let me show you. H, right, whatever C sine A is, I'm going to put it here, and whatever whatever R is, I'll substitute it in here. So you can see that A square is equals to C sine of A square, okay, plus B minus, because H is C sine A, right? So I put in C sine A, and since R is C cosine A, I put in C cosine A. C times cosine A, so C here, squared. And if I open up everything, you get C squared times sine square A plus B squared minus 2BC cosine A plus C squared cosine square A squared. No, cosine square A. which you can see that here, is yellow. This one and this one, I can make it into c squared of sine square a plus cosine square a plus b square minus b 2bc cosine a. And sine square plus a plus cosine square a is 1. It's in trigonometry identity. So we get c square plus b square minus 2bc cosine a. So this is the proof for the cosine rule. Yep, so this is the end of the video for sine and cosine rule. You don't have to be too worried about the proof, just know how to use it, alright? And if you're interested, of course, it's good to understand the proof. Alright.